This is kind of the big one. Well, the next one is kind of the big one. But we're going to be talking about factoring trinomials in the form x squared plus bx plus c equals 0, or solving quadratic equations that look like that. We're going to start by factoring them, and then we'll throw in an equals 0 and remind ourselves what to do with that. Let's dive in with some examples. The only way to get better at factoring is to practice. And so we're going to do several examples, and we're going to assign several practice problems for those of you who are my students, and all of those things. And we're gonna practice to make sure you got this. Once you kind of get it down, they start to become pretty easy, honestly, but it takes practice to get there. And so let's dive in with some examples. So, examples, and number 1. All right. First one is x squared plus 9x plus 20. Excuse me. So, in order for something to be factored or fully factored, we've kind of seen this in some of our previous lessons, but you want it to ultimately be, this is kind of a reverse, a undoing of the distributive property. You want to turn it into, instead of being a sum of products, you want to turn it into a product of sums, right? We've got to turn it into something like this, or you could have even more, right? Whatever else, right? So where you've got all these products and with sums inside of them, they could actually, they don't have to be sums inside of them. It could be more just single numbers or whatever. Because if you do prime factorization, like you take a number and you split it and you split it and you split it. I don't know if you've seen prime factorization before, but something like this, and then you've got all the numbers multiplied to get the big number. So we're trying to split this into something that multiplies to get the top thing. That's our goal here. Now, the steps that we're going to take to accomplish that goal are fairly straightforward and consistent when we're factoring trinomials. Now, in this lesson, we're doing stuff where this first term, this first coefficient, this a1, the number in front of the x squared term is 1. And so these are actually fairly easy. I'm going to end up saying a bunch of extra words that it seems like I'm just saying more words than are necessary. And the reason why I'm saying those is because of when we jump into our next lesson where this a is not 1 and it's some other number. And so we have to have extra thoughts and ideas. So the first step to solving one of these things is really, really simple. I think we can handle the first step because the first step is to just do 2 sets of parentheses. That we can handle, right? Now, once we've split it, right, we have 2 slots in each parentheses set. We have these first slots and we have the last slots, right? And then if you've learned FOIL, you have, when you're multiplying, you have the inside and you have the outside and all of those things. All right, let's see if we can start figuring out what goes inside these slots. So for the first slot in here, we want 2 things that multiply to get the first term. So multiply to get x squared. So 2 things that multiply to get x squared are x times x, right? Excuse me. So we're going to, by the way, you want to do these in pencil, by the way, or erasable pen, or get the whiteout ready, because we're going to learn to solve these using a method called guess and check. And so you're going to, especially when we hit the next lesson, you're going to guess wrong and then have to erase and try again. So for the first slot, we're going to put x and x. Now, for the last slot, we want 2 things that multiply to get 20. So I'm going to list the factors of 20 over here, not the multiples of 20, because that'd be 20, 40, 60, 80, etc. We want the factors of 20. So things that multiply to get 20. So 1 times 20 equals 20, right? 2 times 10 equals 20. Let's see, what else? 4 times 5 equals 20. And there's all the factors of 20. Now, we can rearrange the order, and it's in the next lesson, the order does matter. In this lesson, not so much. So I'm going to kind of intentionally guess wrong here so we can understand what we're doing and what we're checking, right? So we're going to guess one of these. We pick one of these sets. So I'm going to put 2 and 10. That sounds great. 2 and 10 sounds lovely. Now, if some of you are watching this and you happen to already know how to factor, then you're like, oh my gosh, that's dumb. Of course that's wrong. And it is wrong. Okay, but bear with me. So the first, after we guess and we put some numbers there, then we're going to do the smiley face. Actually, I like to call this guess and check method the smiley face method because of this, because we're going to do a smiley face. We're going to draw the nose and the mouth. And then we're going to multiply along those lines. So 2, just the numbers. We don't care about the letters so much. 2 times 1 is 2. 1 times 10 is 10. Now we're trying to either add or subtract to get this middle number right here. So can 2 and 10 either add or subtract to get positive 9? 2 plus 10 is 12. Negative 2 minus 10 is negative 12 or positive 8 or negative 8. So it doesn't work. So that one doesn't work. So we're going to erase it, and we're going to try one of the other factors. Now, if you're following along and you're paying attention, you might already recognize that if we put a 4 here and a 5 here, then 4 times 1 is 4, and 1 times 5 is 5, and positive 4 plus 5 equals 9. So this one works. So then what we're going to do is we're going to follow our mouth over here and put a plus, and follow our nose over here and put a plus. So this is now completely factored. A good way to check this problem, if you want to do a check, would be to distribute this back out, and you should end up with this number, right? Let's do a second example. Let's throw an equals in there this time. Hand tool, learn more. No. Could y'all even see that? Who knows? Can y'all see that? Yep, you can. That's okay. All right, let's do another example. Example number 2. X squared plus 9x. Oh, this is the one we literally just did. Try again. How about x squared minus 8x? Minus 8x plus 20. I'm stuck in the past. 12. I did say to use pencil, right? What was that first step? The first step was easy, right? 2 sets of parentheses. If you can't do, we were going to throw an equals in there, weren't we? Equals 0. Okay, first step is to factor this guy. First step to factor it is 2 sets of parentheses. If you can't get at least 2 sets of parentheses step, then I don't know if there's hope for you. All right, so 2 sets of parentheses. First law is 2 things that multiply to get the first term. So x and x. X times x equals x squared. The second one, we want 2 things that multiply to get 12. So we could use 1 and 12, 6 and 2, 3 and 4, right? We're trying to add to get negative 8. So let's do, how about 2 and 6? Because 2, I'm struggling with the whole writing thing this morning. And 6. 2 times 6 is 12. Then we're going to smiley face that thing on down. 2 times 1 is 2. 1 times 6 is 6. We're trying to get negative 8. Right? So can we add or subtract these to get negative 8? Yes, we can, right? Because if they're both negative, then the signs are the same. So we add and keep the sign. So this is negative 8. We follow the nose up here, put a negative. We follow the mouth over here and put a negative. So now we have this completely factored and equal to 0. A nice thing about that is if we have something completely factored and equal to 0. So if we have something, this product over here equal to 0, then we can split this into two equations and set each one of those equal to 0. So that's what we're going to do here. We're going to take them and we're going to split it. I'm going to rewrite it here so we can see what's going on. X minus 2 times x minus 6 equals 0. So we can now split this into 2 and split it into x minus 2 equals 0 and x minus 6 equals 0, right? So now we can solve each one of these little baby equations. For this one, all we have to do is add 2 to both sides. My 2's in the last couple of days, both in class and out of class, have been having this little, like, well, I don't even know how I'm doing it. I keep drawing them stupid. So, there it is. It's okay. On this one, all we have to do is add 6 to both sides. These cancel, leaving us with x equals 2 and x equals 6. So both of those answers, either one of those answers, we could plug in up here and it'll make the equation true, right? So let's do one more. Yeah, one more. I think that sounds reasonable. Okay, one more, and then we'll be done with this lesson. And in the next lesson, we'll look at a little bit more complicated E1s. And it's going to be a great day to be alive. Okay, so example 3. Example number 3 is x squared plus 2x minus 15. This time we won't throw it into an equation. We want to make sure we understand that you won't always have an equation. If you have an equation, you get number answers. If you don't have an equation, you get expression answers, right? So our first step, what was that easy first step? 2 sets of parentheses. First slot, 2 things that multiply to get the first one, x and x. 2 things that multiply to get the second one. So we got 15. So 15 and 1, 3 and 5, right? So let's do 3 and 5. Now we're going to smiley face. Whoopsh, whoopsh. 3 times 1 is 3. 1 times 3 is 5. I don't know where my brain and my mouth disconnect is. 1 times 5 is 5. Okay, so we're trying to get a positive 2. Now, this one's a little different. Can we either add or subtract those to get a positive 2? Well, yes, we can. If the 3 is negative, we'll end up with a positive 2 because negative 3 plus 5 is 2. So we're going to follow the nose up here and put a minus and follow the mouth over here and put a plus. So our final answer is x minus 3 times x plus 5. That's it. We're going to do another one of these. I may throw in a lesson on the box method for solving them after the next lesson. We shall see what kind of time is permitting and all of those things. But we will see you there if you're one of my students. I look forward to seeing you in class. If you're not one of my students, thanks for joining us. We have more things that we're doing over at emberlearninglabs.com. This entire Algebra 1 course is available for free here on YouTube. Thanks for being here. A like and maybe a comment on how we can help you out, and a subscribe would be wonderful. Thanks. Have a wonderful day. Bye-bye.